Okay, welcome everyone to the webinar, New Perspectives on Lifespan Inequality. I'd like to thank the Herzig Institute at Tel Aviv University for hosting this event, to my co-organizer at the University of Southern Denmark and the Oxford University, Virginia Zaruli and Jose Manuel Aburto, to the speakers, of course, and to everyone who has joined us. Last spring, we had planned to hold the second Tel Aviv seminar and workshop on lifespan inequality. As many of you know, we had to cancel this event, unfortunately, as many other events due to the corona pandemic. Now, today's event is a way for us to keep in touch with the research community, to exchange ideas, but it is by no means a substitute for the main event, which we're still hoping to hold next year, or whenever it becomes possible. So first of all, stay tuned for what is to follow. And today we'll have just a couple of sessions from what we had planned for the main event about lifespan inequality. The concepts of lifespan inequality and lifespan variability have been around in demography, I think, for over two decades now, at least the way we understand them now. But I think the field has really taken off in the last decade, and is turning into, or at least starting to turn into, a coherent research agenda. And I think the speakers today have all had a part in making this happen by improving our theoretical and methodological understanding of inequality in length of life and moving beyond basic measures such as group differences in life expectancy. But I believe we still have, we need to make additional steps forward to bridge the gap between theory and methods, to sort of improve the link to the philosophical understanding of what it means for lifespans to be unequal, in the same way that I think income inequality in economics, for example, has gone through over time, over several decades. So I think we're not there yet, but I think we're getting closer, and maybe we'll get a little bit closer today toward this coherent research agenda. Today, we'll hear some new ideas about conceptualizing and measuring lifespan inequality. We'll venture into new territories in which the concept can be applied fruitfully and successfully. We'll have time for a couple of brief questions after each talk, but at the end of the webinar, we really hope to have an open discussion, hear more ideas, more voices. So I hope everyone stays to the end of the event. We'll also take a 10-minute break in the between sessions. Maybe I should share the program. So we'll take a break between sessions, because I know it could be pretty exhausting to sit in front of Zoom all day. And next I will turn it over to Jose Manuel, who will moderate the first session. We have a fantastic lineup of speakers. So take it from here, Jose.
Thank you, Isaac, and thank you everyone for attending the webinar and the speakers. It is my privilege to introduce our keynote speaker, Professor Hal Caswell. He is Professor of Mathematical Demography and Ecology at the University of Amsterdam. His vast research focuses on population models for humans, plants, and animals. His elegant treatment of linear algebra and calculus to analyze stochastic processes in demography is familiar to many of us and has been inspirational to many demographers. He is recipient of not one, but 2 ERC advance grants, among many other honors and awards. And among other projects, he is currently leading the ERC Advance Grant on the formal demography of family and kinship structures. He is author of several articles and multiple books, including the influential Applied Mathematical Demography with Nathan Kiffitz, and more recently, Sensitivity Analysis, Matrix Methods in Demography and Ecology, which I believe is also open access. So Professor Hal Caswell, we are thankful that you have accepted to be in this webinar, and the floor is yours.
Thank you. Can everybody hear me okay? Yes?
Yes.
Good. All right. Let me just start my stopwatch here so that I will actually have some idea of how long I'm taking. And so before I start sharing my screen, I'm going to try today to talk about some things that I have been thinking about in terms of lifespan inequality, lifespan variance. And in particular, my goal is to suggest that we need to think carefully about how deterministic and stochastic sources of variance interact with each other when we're looking at something like inequality in lifespan. And let me start off and show you what I mean by that. I'm going to share my screen. I'm going to go here. Okay, slides are there?
Yes.
Yes, good. Whoa, come back here. So in my title, I used the term real inequality, by which I mean inequality in socioeconomic, environmental conditions that people live in. Everybody knows that the dice are loaded. Inequality in terms of income, in terms of wealth, in terms of education has been rising in lots of the developed world. And this has demographic consequences. This slide I will return to a number of times is from a study that came out a couple of years ago in the Journal of the American Medical Association. This graph on the left shows, as a function of age, from age 40 to age 90, the mortality rate on a log scale. This happens to be for men. The one for women looks very similar. For the 5th percentile of the income distribution in the United States, and for the 95th percentile of the income distribution in the United States. Poor people have much, much higher mortality than rich people. They actually have this for every percentile. So there's 100 of these lines. They all look the same. They showed 2 of them. And this translates into these survival curves. This is just another example of this. This is from a report from the UK. This is a deprivation index from really bad conditions to really good conditions. The green line is disability-free life expectancy. The black line is life expectancy. The scatters around that are neighborhoods defined in some way in this thing. And you can see that living in a lousy neighborhood costs you in terms of your healthy longevity and in terms of your overall longevity. So this is all standard stuff, and in this venue, everybody kind of knows this. The people measure inequality by looking at a distribution of something. This is the distribution of household income in the United States. This is the distribution of household income, I think, in the Netherlands. I think I dug this out somewhere. And given a distribution like this, you need some measure of how spread out it is to talk about inequality, and you can use variances, standardized variances, standard deviations, Gini coefficients, measures of concentration, the share of the income that goes to the top 1%, a whole list of these, mostly highly correlated with each other, which brings us to this graph, which we also have all seen. This is the distribution of longevity, distribution of lifespan in Sweden, as it turns out, in 2 different years. There's a lot of variability in lifespan. It has changed over time. A bunch of infant mortality went away. The overall distribution shifted to older ages, and the spread of this distribution got squished up and shrank a little bit. And there's now a well-documented relationship between changes in life expectancy and changes, changes in some measure of the disparity, the distribution, the variance in lifespan. And this is an example from a paper that Alison was involved in showing life expectancy and life disparity. And this is driven by a thing which is also well known now, that the sensitivity of any of these measures of variation, this is the standard deviation, to changes in mortality has this shape. It's positive up to some age and negative beyond that age. So if you reduce mortality at early ages, you reduce the standard deviation, you reduce inequality in lifespan. If you shrink mortality at older ages, then you have the opposite effect. But you need to think about where the variance comes from. There's two sources of variance in something like this. One is luck. One is just the random outcomes of probabilities being applied uniformly and to individuals, all subject to the same rates, but having different outcomes. The other source is what you could call heterogeneity. Individuals differ in some way due to differences in some kind of properties, their income, their wealth, their frailty, their history, their genetics. And those differences translate into differences in the rates that they experience. So that's the difference between the mortality rates experienced by the rich people and the poor people in the first graph that I showed. This graph and any distribution like this that is calculated using life table methods has no heterogeneity in it other than age. The calculation of this distribution explicitly says that you have a cohort, and at every age in that cohort, everyone flips a coin with exactly the same probability of success to live or to die. And so this distribution represents the outcome due to stochasticity of the life table from which you calculated. But if you actually do have some heterogeneity, if you do have some inequality, rich people and poor people, whatever it would be, then you have the ability to partition the variance into those two sources. And this is a well-known formula in probability theory and in statistics. If you have some set of groups, income groups, education groups, whatever they are, and you know you have some proportions, like those are percentiles or whatever the proportions are, then the variance in whatever it is you're looking at has two components. One is a within group component and the other a between group component. The within group component is the variance that comes from what happens to individuals uniformly within each group. The between group component is due to the differences between the groups, between the heterogeneity groups that exist in the analysis. And a standard thing to do is to calculate the variance ratio or the intra-class correlation coefficient, which is simply the fraction of the overall variance that's due to the variance between the groups. And this is easy to calculate, and there's extensions to use to do it for multi-state models and for healthy longevity and for dynamic heterogeneity and all kinds of really cool, fun things. So I want to look at some cases. I want to look at what happens when we look at lifespan variability in this way. So that's going to involve choosing some kind of group, some dimension of real inequality, differences that individuals experience, calculating the means and the variances, the within group and between group variances, and then finally this variance ratio, the fraction of the variance due to the inequality. So I'm going to start with this Chetty et al. Study of mortality and income in the United States. So we have actually 100 percentiles from the first percentile to the 100th percentile of income and we have mortality rates for those. They did a bunch of things to get those, which it's a long paper, and I'm not going to try to summarize it. Here's the mean longevity, the mean lifespan, the life expectancy at ages 40, 50, and 60. I just picked those out as a function of the income percentile. And you can see that being in the bottom percentile costs you about 7 years of life expectancy compared to being in the top percentile of income distributions. This is a typical kind of difference for lots of dimensions of inequality. This is the variance in lifespan within each of these income percentiles, again, for these 3 ages. And you have these variance patterns. When you calculate the variance due to the within group variance, the variance due to stochasticity goes down with age, starts at about 100 and goes down to 0 because everybody dies here, so there's not any more variance left. This is the variance due to inequality. This is the variance due to the distribution among the income groups. It starts at about 4 and goes down to 0. You can see what the ratio is going to come out to be. The variance ratio is about 3.5% down to close to 0. Is the fraction of the variance in longevity that is due to the inequality in income. The rest is due to chance outcomes of survival rates applied over a lifetime. This is another example. It does a very similar, presents a very similar thing. I like it because they did inequality due to income, inequality due to education, and inequality due to occupations. And for income, being in the first quartile as compared to the fourth quartile costs you about 5 years of life expectancy for men and about 4 years of life expectancy for women. If you calculate the variance components, the variance in lifespan due to income in this set of data is about 3% for men and 2.5% for women. If you look at education groups, they had a low and a medium and a high education group. I don't remember how those were exactly defined, but being highly educated gains you about 7 years as a man, about 3 years as a woman. The fraction of the variance due to inequality in education is 5% for men, 1% for women. This is a study that we did just a little while ago, looking at deprivation scores, a measure of how bad your neighborhood is to live in Scotland. And for males, about somewhere from 1 to 4% of the variance in longevity was due to the differences between living in a really good neighborhood and a really bad neighborhood. And for women, it was 1 to 2% of the variance. Sometimes you don't necessarily measure the inequality components like knowing income or knowing how good your neighborhood is. So this is a study using the Gamma-Gompertz-Makeham frailty model, which has a latent frailty variable that modifies mortality in a particular way and is assumed to have a gamma distribution. And so with Nika Hardemek and Trifon Missoff, we did an analysis. This shows the variance in remaining longevity at age 40, cohorts going from way back when up to much more recent cohorts for Italy, France, and Sweden. The numbers don't matter. The little dark line on the top, That's the variance in longevity due to the heterogeneity, or the inequality, if you will, in frailty. It's about 5% of the total amount of variance. The rest is random outcomes of mortality rates being applied over the lifetime. So maybe there's just not enough inequality in these. I mean, yeah, income and neighborhoods and frailty, but maybe the effect just isn't big enough. Maybe we need to find something that has a bigger effect. So this is a study on inequality in early life nutrition. And there are 24 different groups of inequality groups in this study. This is life expectancy. It goes up by a factor of 6, depending on what kind of nutrition you had when you were young. These are the survivorship curves. I submit that you will never find a dimension of inequality in human populations that would show you that range of differences in survival curves. This is an experiment on the Mediterranean fruit fly, the larvae of which eat fruits, and different fruits do more or less well at producing healthy adults. And the variance due to the food sources and the variance due to stochastic outcomes leads to 15% of the total variance being explicable by the diets. Maybe there's still not enough inequality. I'm going to skip over this one, but you can look across species and you only manage to get up to 25 to 30% of the variance. So longevity, or lifespan, is subject to a lot of individual stochasticity because it's an integrated hazard. It's flipping the coin over and over and over and over and over again. And you get this big distribution of when the coin finally comes up saying that you die. We've seen this sort of thing before, and you can ask, what should we do about it? And so there are 3 different approaches that I have thought about with this. One is to forget about the between group differences and focus on the variance within group variance. A famous study in the 1970s by the geneticist Richard Lewontin was the first study that was able to look chemically at genetic variability. And he was interested in the question of whether racial groups, what were being treated as racial groups in genetic studies at the time, how much did those groups contribute to variance in genetic structure? So he did a bunch of analyses and found that the between group differences, the group differences interpreted as racial differences, contributed only about 6% of the variance. And he had this to say about it: human racial classification is of no social value and is positively destructive of social and human relations. Since racial classification is now seen to be virtually no genetic or taxonomic significance, no justification can be offered for its continuance. So if we did this, we would be forced to say that those differences in the means between poor people and rich people, or lowly educated and highly educated people, we aren't going to pay any attention to those. We're just going to study the variance. And although it seems acceptable to do that with racial classifications that have caused so much damage, I don't think people would be happy with being told that the life expectancy differences don't matter. If you do this, you can begin to treat variance and longevity as a kind of inequality. The best statement of this that I know of comes from a paper with Alison and inequality in the length of life is the most fundamental of all inequalities. Every other type of inequality is conditional on being alive. And there's questions raised about whether the extreme case of that would be a rectangular survival function where everybody dies at the same age and there's no variability in lifespan at all. Not everybody wants that. These psychologists did a study asking a bunch of people in a very formalized way, would you want to know today when you will die? 87% of the people said no, they didn't want that. And 87% of them also didn't want to know from what cause they would die. A second approach,
left, Hal.
Thank you. A second approach is to ignore the within group variation and focus on the between group variation. That is, pay attention to those differences in life expectancy and not the differences in lifespan that come about because of chance or luck. And these people, including Christopher Murray, a paper in 2000 talking about inequalities in health, they opted for that approach. They said, we're not interested in the inequality that has arisen from chance or luck, since at the outset, all individuals had exactly the same risk. All individuals were being exposed to the same risk and differing in their outcomes due to stochasticity. That doesn't seem totally satisfactory either. I have been thinking, and I want to offer this as a thing that might be worth exploring in relation to the developing approaches to variance in longevity. Switching attention from longevity to risk. As demographers, we're used to thinking about life expectancy, which is the mean of longevity, and from there to the variance in longevity. But those are demographic outcomes of things that happen to individuals every day. And I think you can make an argument that what counts to individual lives is how likely are you to die today? What kind of risks are you facing today and tomorrow? And I get the image in my mind of the pictures that you see of people worried about going out their door because somebody might shoot them. And what kind of measures can we come up with that measure inequality in terms of risk? So going back to this study again, there's 100 of these lines representing the 100 percentiles of income from the very poorest to the very richest. And if I calculate the relative risk, the ratio of the mortality risk at 1 percentile to the mortality risk at some chosen reference percentile. Here I've chosen the 100th percentile, the rich people. Then this is what comes out as the relative risk. If you do the odds ratio, for those of you that like that, it's indistinguishable from this with these values. So it's the same thing. So at age 40, a person in the bottom of the income distribution has a mortality rate 15 times bigger than the mortality rate of a 40-year-old person in the top 1%. The risk ratio it goes up to 15. Here it is around 10. At age 50, it starts a little lower. At age 60, it's a little bit lower. So look, I calculated these just recently, and I thought, well, those look awfully big. I invite you to think about whether they're big. You see risk ratios, relative risks, reported in lots of medical studies where you want to know the relative risk caused by health behavior or by some other factor, or the relative risk of having versus not having a treatment or a drug. So I found this. The one thing that we all know is a major, major, major mortality risk is smoking. And a couple of years ago, the Public Health Service in the United States put out a review of 50 years since the original report on smoking. It's literally 1,000 pages long, and it tabulates study after study after study that has been done calculating risks of different kinds of outcomes due to smoking. And so there's pages and pages and pages and pages and pages of this. These are studies of the risk of, what is this? This is with all-cause mortality, but they have all these. So I skimmed through these. The relative risks for smoking and not smoking, for things like all-cause mortality and risks of all kinds of other things, tend to be between 1 and 2, sometimes as high as 3. I found one study in their meta-analysis here. I found one study that had a relative risk almost up to 5. So this line on this graph is a relative risk of 1. And this one is a relative risk of 2. This one is a relative risk of 3. So basically, being poor in the United States is a significantly bigger risk to your mortality than smoking. That seems like a pretty powerful suggestion that this income inequality is a real thing. And I wonder if we can somehow integrate these kinds of measures of risk, which focus on the mortality happening at particular ages, and integrating that with calculations of longevity, which integrate risk over ages to calculate survival probabilities. So, concluding, longevity has all this stochastic variation in it, and at least a bunch of studies, inequality in income and education and occupation, things like that that really matter in people's lives, contributes only a relatively small amount of that variance. So it's not providing a strong signal. The variance in lifespan is not providing a strong signal of the variance, the inequality in things like income and health. Yeah, we need to figure out what to do about this. I'm not quite sure what we should do. And I'm going to stop at that point and thank everybody. And I don't know who's listening out there in Zoom land, but I'm going to be looking for a postdoc or a couple of postdocs at some point to work on the kinship analysis that was mentioned, Jose mentioned at the beginning of the introduction of me. So contact me if you're interested. Thank you.
Thank you, Hal. I'm gonna clap here on behalf of everyone. Thank you for such an interesting presentation. I think this how do we interpret lifespan inequality, lifespan variation is very interesting topic, and this approach that you have presented today on between and within inequality is definitely a very interesting one. I've been also thinking on the other topic that you touch upon on how do we as individuals interpret the uncertainty around our life, our death, and whether we actually take information on on our surroundings, on mortality to, for example, decide whether to take a risk or not at some point in our lives. And I think a lot of us have been thinking on this. At least I know Alison and Iñaki have been also thinking on this. And it's remarkable the differences that you look at least between countries. For example, in Mexico, it's not uncommon to hear this phrase of, oh, I better do it today because tomorrow you never know. We might not even be alive. Well, it actually, in developed countries, you actually know that you will be alive. and it's remarkable that a demography paper a couple of years ago, using a French survey, asked individuals about their uncertainty around life, and they match pretty well the life table variance of that year, which is quite remarkable. So I think this opens a lot of new research questions. So thank you very much. At least I take a lot from this presentation. And I don't see there are any questions on the chat. So okay, there are two. So I don't know, maybe if this can be answered in a couple of minutes, then we can go through them. Otherwise, we'll go to the next session. So Ilya Kaczynski is asking if are the between group variance contributions of income, education, etc., whether if they are mutually exclusive. Hal, would you like to answer to that?
Yeah, Ilya, thank you. Good question. In the way that these are set up, each one is treated as a one-way classification. That is, individuals have heterogeneity in income. Let's calculate the variances. All right, done. Individuals are have inequality in education. Let's calculate the variance. There's a joint distribution of income and education, but that doesn't get reported. So if you had that, then you could ask, within the population, there's individuals differ in the joint quantity income and education, and then you could partition variance due to that joint quantity, and then with a little skill, you can partition that into an income contribution, an education contribution, and an interaction between the two. And I've been working on that, but it gets a little bit complicated. It's made me go back and read really old papers about analysis of variance, and they're confusing. But so if the joint distributions were available, then there would be the opportunity to look at how different kinds of heterogeneity interact with each other.
Yes. Thank you, Hal. I think, yeah, probably we can discuss this further because Ilya is co-author, I think, of a paper also that looks this overlapping of the distribution. So I think that's probably why he's also asking this. There are a few more questions that I will, including from Rudy Kashap, and Roberto Salguero says that he really enjoyed your talk. So I will take note of them and then go back at the end of the session. So we'll try to now go with Alison to her presentation to keep on track with the program. And I'll make a brief presentation of her. So I'm thrilled to introduce our next speaker, Dr. Alison Vandralte. Alison's research over the last decade has focused on studying mortality patterns and lifespan inequalities in multiple countries and also between socioeconomic and educational subgroups. She has authored several articles on the topic in leading journals of demography and epidemiology, including an influential article that was quoted by Hal in Science Magazine's Policy Forum in 2018 on the case to monitor lifespan inequality, where they document the double burden of shorter and more variable lifespans among disadvantaged groups in Finland. She is currently head of the Lifespan Inequalities Research Group at the Max Planck Institute for Demographic Research, funded by her ERC starting grant. She additionally contributes to the formation of young demographers, teaching the introductory course on demographic analysis at the European Doctoral School of Demography. And I was very lucky to have Alison as my supervisor during my PhD. Her feedback, support, and supervision were invaluable during the process. So without further ado, the floor is yours, Alison.
Thank you, Jose Manuel. And thank you for the kind words. I'll just share my screen here. we go. Everyone can see that, I assume?
Yes.
Yeah, okay, so I'll just get started. So I want to start just by, of course, thanking the organizers. It's really a pity that we couldn't be in Tel Aviv right now, although it's sunny in northern Germany, if you can see the background, which is rare. But I do hope to get to Tel Aviv again at some point. And in the meantime, I think it's absolutely terrific how large an interest in lifespan inequalities we were able to generate over the internet through this webinar series. So maybe it's opening up new possibilities for collaboration and shared interests, which I think is awesome. So my talk today is going to be a little bit on the technical side. Specifically, I'm going to be talking a little bit about something that I have only recently been thinking about, and this is how to think about relative measures of inequality when we're looking at conditional distributions. So something rather specific that was sort of came out of a discussion with many of the organizers of this webinar, as well as some of the presenters today. So to start with, as has already been alluded to, a couple of years ago, we tried to make the case that we should start measuring lifespan inequalities, particularly by subnational groups, because they tend to show very different things than if we are only looking at mean differences. So on the left here, we have trends. Well, this is actually, oh, pardon me. This is trends in life expectancy or average age at death, conditional upon survival to age 30 by level of education among Finnish females. And if you look at this figure, the takeaway message is that all groups are experiencing increases in their average age at death. And these are more or less going in parallel with one another, although there has been some widening. When we look instead at trends in lifespan variation, in this case measured by the standard deviation, we see a very different story. So the high educated group are experiencing declines in the standard deviation, whereas the low educated groups are experiencing increases in lifespan variation. So what this means is that the low educated group is becoming more heterogeneous. And if we think about it as also a measurement of the uncertainty in the timing of death, the low educated are actually experiencing more uncertainty in when they will die, even if their lifespans are increasing. And now, so an open question is just how representative are these trends? So Isaac has shown that in the United States, there's also been quite a lot of divergence by educational groups. Iñaki has also shown the same thing for Spain. And in a more recent study, we have just started gathering data from, well, basically as many European populations as we had data, and for as many different time periods. So this is data coming from the LifePath Consortium that is run by, or at least for this section of it, by Johan Machenbach at Erasmus University in Rotterdam. And when we look at trends in the average age at death, this is conditional upon survival to age 40, we again see that across all of these European countries, everyone has been experiencing increases in average age at death. And among all different levels of education, these trends have been increasing more or less in parallel, not everywhere, but for the most part. And now turning again to the standard deviation, we already saw trends among Finnish females. Now here are the trends among Finnish males, which are fairly similar. And that does seem to be a little bit on the more extreme end. However, there has been divergence by level of education in most countries. To more clearly see this relationship between the standard deviation and the average age at death, we can put them together. So here we have the average age at death on the x-axis and the standard deviation in survival age on the y-axis. I've also added updated US results or US data from Isaac. And what's remarkable is that among the high educated, there's really quite a tight relationship between the average age of death and the standard deviation in survival age, meaning that as these groups are experiencing increasing average ages at death, the variability is declining. And among the low educated, there really isn't much of a trend. If anything, they are also experiencing increases. And at any given average age at death, there are huge differences across countries, huge differences for any time period. So the time periods are given by color. So it's really going against this strong negative correlation between life expectancy and variability that we have mostly seen at the national level. Now, the standard deviation is measuring absolute inequality. What about trends in relative inequality? So to sort of take a step backwards, we have a number of different measures of inequality that we can use. This is a non-exhaustive list, but this is probably the measures that are used most often in demography. And many are in the same family. So there's the standard deviation, and if we divide that by the mean, we get the coefficient of variation. Many of you are familiar with the Gini coefficient. If you multiply that by the mean, you get the absolute Gini, or the absolute inter-individual difference, it's sometimes called. And then we have the life disparity measure from the life table. When we divide that by the mean, we get the life table entropy, or the K-Fitts laser entropy. And then also used quite often are sort of quantile or percentile based measures, such as the interquartile range. You can make those relative, but it's not necessarily clear if you should use them, divide that by the mean or by the median. And then there are a host of relative inequality measures that are mainly entropy measures, like the tile index and the mean log deviation, which are used often because they're additively decomposable, but they don't necessarily have an absolute inequality counterpart. And just to define some terms here, so absolute inequality measures are measures such that if you increased everyone's life by the same amount in years, the value would remain unchanged. We call this translation invariance. So you could basically just shift these distributions of ages at death along the age axis, and the measure will not change, which isn't the case for the relative measures. The relative measures are ones where if everyone's life is increased by the same proportion of their life, the value would remain unchanged. So one way to think about that is to sort of keep that distribution of ages at death in a fixed position, but then we, along the age scale, we multiply those numbers by some proportion, and you would still get the same value. Sort of keeping with definitional ideas here, we can also talk about attainment and shortfall distributions. And this is where things start to get interesting. So when we think from birth, we can look with the age at death on the x-axis, and we can look at our distribution of ages at death with a proportion going here. The mean age at death would be 65 years. Now let's condition these distributions upon survival to age 30. So we're looking at only people who are, we're conditioning on survival to age 30. We have a new distribution, and in this case, the mean rises to 67.5. We can do the same thing for age 65. Now let's think instead of a shortfall distribution. These are exactly the same distributions. What is changing is the x-axis here. So when we have all ages, the remaining life expectancy at birth is exactly the same as the mean age of survival, 65.3. Nothing has changed. But when we start looking at conditional distributions, then instead of having the distribution of attained ages, we have the distribution of remaining life years. So remaining life expectancy at age 30 is 37.5, which is 30 years younger than the mean age at death conditional upon survival to age 30. And we can do the same thing for remaining life expectancy at age 65. So clearly, I haven't changed the distribution. What I'm changing is the semantics, if you like. Now, why does this matter? Well, when we're making relative measures, it's this mean that goes into the denominator, and it matters what goes into the denominator. So if we are thinking, if we're using conditional measures, if we look at the proportional changes in the average age at death, so this is the attainment distribution here in the dark blue line, that will be different than the proportional changes in remaining life expectancy, this sort of light blue line. And the older we condition our survival upon, the more changes we have. Now I have cherry picked using Russian men because Russian men have experienced a lot of mortality changes over these years, but this is something that is that would be seen across most populations. And when we're calculating a relative measure of inequality, so this case I've stuck with the family of the standard deviation and the coefficient of deviation, or the coefficient of variation, sorry. The coefficient of variation then will be the standard deviation divided by one of these means. In the case of an attainment distribution, we'll have the gray line. So that's dividing by the distribution of ages at death, achieved ages at death, conditional upon survival to these different ages. And the orange line is the coefficient of variation that comes from a shortfall distribution. So that's dividing by the distribution of remaining life expectancy. And particularly as we get into older ages, these are actually even showing us completely different directions in trends, because the difference in the proportional change in the average age at death is so much smaller than the difference in the proportional change in the remaining life expectancy. So returning to our example of socioeconomic inequalities, how much of a difference is it going to make when we look at achievement distributions or shortfall distributions? On the right here, this is the coefficient of variation based on the distribution of remaining life expectancy. And these are the coefficient of variation figures based on the distribution of average age at death conditional upon survival to age 40. What we see then is, looking at the achievement distribution, or the average age at death, the figures fall something in between what they would look like if we look at the shortfall distribution and what we saw when we looked at the standard deviation. So in other words, when we're looking at, so the main takeaway message is that when we're looking at these shortfall distributions, we get very tight correlations between the coefficient of variation in remaining life expectancy and changes in remaining life expectancy. We even see this sort of negative correlation even among the low educated groups, where if you remember when we looked at the standard deviation, it was actually an increase in variability that happened alongside increasing average age at death or remaining life expectancy.
2 minutes, Alison.
Okay, and then when we turn instead to the achievement distribution, it's, as I said, something in between. These trends are pretty flat with increasing average age at death. So to sort of summarize here, this isn't really a new thing that I'm showing. This has been long recognized in other domains of inequality, and I want to thank Iñaki Permanier here for turning me to some of this literature. But in demography, we haven't really engaged with this literature. And in fact, when we've been using conditional distributions, which we have done for a number of reasons, both because we often don't want to be overly influenced by infant mortality. So sometimes we've been looking at distributions conditional upon survival to age 10 or 15. When we've been looking at socioeconomic differences, we're often forced to look at conditional distributions because we have to wait until people have achieved an own socioeconomic status. And if you look across papers in the literature, the choice of whether we've been looking at the distribution of attainment distribution, so the distribution of average age at death versus the distribution of remaining life years, this has actually been generally made based on the choice of the measure. Rather than for any kind of normative reasons. And I don't think we've really thought so carefully that this can actually be telling us different things. So there are some potential solutions. I don't really have time to go into it, but there's a fantastic paper in the works by Iñaki Permanier and Jiajin Shi looking at normalized inequality measures. And these have the advantage that they will give the same result for both attainment and shortfall distributions. And they will also give the same result for absolute and relative measures. Now, the downside is that by normalizing them, they're sort of taking us one step away from the interpretation of, some of these measures are already fairly interpretable, and it's a little bit harder to interpret through the normalization procedure. Otherwise, we just have to sort of address that there is ambiguity when we're measuring these things. And this sort of goes back to a lot of the stuff that Hal was saying in his presentation, and to one of my favorite papers, which is the Kafitz and Golini paper, that asks, is male mortality 10%, 50%, 80%, or 70% higher than females, depending on what we're actually comparing between death rates between the two sexes. So to sort of conclude, I don't think there is a right way to measure relative differences in mortality. So I don't think it's right to look at attainment or shortfall distributions, but I think we have to recognize that we need to be clear about the terminology. So if we're measuring relative variation in distributions of remaining life expectancy, we should be avoiding terms like lifespan variation or age at death variation, and really instead be clear that we are measuring variation in remaining years, or the remaining lifespan variation. And on the contrary, when we're measuring variation in the distribution of ages at death, we should also be clear about that. And I also think it's probably good practice to show trends in both these attainment and shortfall distributions. And again, I want to thank everyone who's been helping me to think a little bit more about this, and I'd welcome any questions that you might have.
Thank you, Alison, for such an interesting presentation. Again, I think you touch a topic that is very relevant for the lifespan inequality literature, because I've read in some papers, and I think I've written this too, is like this: I chose this indicator, and it really doesn't matter because there's a high correlation between them, and we give for granted that, oh, because they're highly correlated, then it doesn't matter. It's good that you show that it actually matters which indicators we use, and also whether we're referring to absolute versus relative inequality or variation. So thank you very much for your presentation. Hal and Alison, there are some questions in the Q&A chat. Some of them might be easy to answer just replying there. If not, then I will summarize and try to have a discussion at the end of the session. Just to stay on track for this one, I'm gonna pass directly to Iñaki's presentation. So I will just briefly introduce him. So Iñaki, our next speaker, has been recently awarded an ERC Consolidator grant to study healthy lifespan inequality after successfully leading his starting grant over the last few years on sociodemographic determinants of the spatial distribution of welfare, based at the Center for Demographic Studies at Universidad Autónoma de Barcelona. He has undertaken substantial research on the measurement of multidimensional gender inequality around the globe, and more recently published the Subnational Human Development Database. He has published articles in prominent journals of public health, economics, and demography, including on the topic of lifespan inequalities. In 2020, he was honored with the European Demographer Award from Population Europe for his contributions to the field. And beyond his achievements as researcher, Iñaki also stands out for his hospitality and availability to provide advice to young researchers, which I have also witnessed. Iñaki, I'm very happy that you agreed to participate in this webinar, and the floor is yours.
Thank you, Jose Manuel. Thank you very much. Thank you to you. Thank you to all the organizers for having invited me. It's really an honor. Maybe I should start sharing my screen. Okay. Can you see it? Yeah, okay. So yeah, I'm going to speak also a bit, I don't know if it's as technical perhaps as Alison, but it also has to do with the measurement, right? It's related to measurement of something which is very similar to what the previous speakers were speaking about. It's not exactly lifespan inequality, but something which I called healthy lifespan inequality, okay? Perhaps some of you already heard about this story. So let me start just summarizing. It's going to be very easy because in this audience, I mean, you all have heard about these population health indicators. We start with the classical life expectancy indicator, which is telling us on average how long are individuals expected to live under current mortality conditions. And well, you know that this is very interesting, but has some limitations. One of the limitations is that this indicator is just telling us about longevity, how many years individuals are expected to live, but it's not telling us nothing about whether these years are going to be spent in good health or not, right? And this is the reason why huge literature has evolved trying to measure something here, which I call these health expectancy indicators. They're trying to tell us on average how many years are we expected to live in good health under current mortality and morbidity conditions, right? This is one, so to say, I don't know if improvement, but another way of looking at life expectancy, looking at the mean levels of this indicator. And another dimension we're interested in, and in this seminar is specific about it, it's not just about the average, but about the variability, right? There's a huge literature, as Jose Manuel and Isaac already mentioned, I mean, in the last 20 years or so, that has been studying this issue of variability, how to what extent the ages of death distributions are compressed or wide out, right? So in this horizontal axis, we have this quantity quality dimension, if you want, and in the vertical one, we have this efficiency and equality dimension. And I was thinking, well, that there's a gap in this diagram. There's something that seems to be necessary to fill, and this little corner here. And I thought it might be interesting to define something which I called healthy lifespan inequality, which it's pretty much the same idea as lifespan inequality itself, but rather than looking at the entire, length of life, it would try to disentangle how much of this entire life has been spent in good health and what part has not been spent in good health, so that we're able to assess the extent to which healthy lengths of lives have been equally or unequally distributed, right? So this is trying to incorporate like these two dimensions at the same time. So this quantity quality, so not just how many years, but the quality of those years, whether they were spent in good health or not. And then these vertical dimensions of equality, right? So basically what I've done in the last, last year, and I'm planning to spend like the next 4 or 5 years in this consolidator grant that Jose Manuel mentioned, is to try to explore like this new family of indicators and try to find out what can we say about these measures of healthy lifespan inequality. Okay. So this is very silly. I mean, this is just an illustrative example to see why this would matter. I mean, this is a very hypothetical example where I have two populations, A and B, where I'm showing like the very different patterns of age and morbidity onsets, right? In population A, almost everyone starts being, in bad health at the age of 60, whereas in population B, we have two clear groups, one starting to get in bad health at the age of 40 and the other one at the age of 80. And both, in both cases, health expectancy indicators would not be able to distinguish among this very obvious case. And of course, this is one of the reasons why we look to look beyond averages and then calculate something which is these healthy lifespan inequality indicators, right? Or another hypothetical, of course, this is not realistic, but just to illustrate what's going on, these are hypothetical mortality and morbidity curves, something similar to what Hal was mentioning, like an almost rectangular mortality curve. But imagine that in this situation where everyone is dying at the same age, we are observing no lifespan inequality, but it might turn out that in this hypothetical example, half of the population is dying at half of the maximal age, and the other half of the population is living in good health up to the very end. So traditional lifespan inequality indicators would fail to identify, this extent of heterogeneity in health distributions, right? That this is why I think these healthy lifespan inequality indicators can be important, right? That the main issue, again, is the fact that current measures of lifespan inequality are one way or another implicitly based on this assumption that the longer, the better, right? But I was wondering, and this is something that, I think all of us agree, right? It's not, perhaps it's not that clear. Perhaps it's just that clear that people are favoring very long, but perhaps not that healthy lives. This is case A, or perhaps shorter lives, but in fully healthy lives. So there's this clear quantity quality trade-off, which, as far as I know, has not been taken into consideration in this in the current lifespan inequality measures, right? And my concern is that including any year of life irrespective of the health conditions in which these years of life are lived, this can muddy the waters, right? As regards interpretation of the index. If you observe a certain amount of lifespan inequality, but it turns out that a big portion of that life has been spent in terrible health conditions, well, it's not that clear what the meaning of lifespan inequality would be, right? So this, what I call this HLI approach, this healthy lifespan inequality approach, would be like an attempt to disentangle or to distinguish between these healthy and unhealthy chunks of life and try to address how heterogeneous distributions are in that regard. Okay, so now it's a challenge for me because I want to summarize 3 different studies. So it's going to be like funny. I mean, I'm not going to go into much detail, but I just wanted to show you very quickly some of the progress I've been doing in the last months with some colleagues. These are very different studies. The first one has to do with the analysis of these previous indicators in different Spanish autonomous communities. The second one is looking at Spain again, not at the subnational level, but across educational groups. And the third one, there's a typo here, that should be a 3. I'm looking also at 12 European countries moving over time, right, between 2005 and 2015. But I'm going to go very quick because basically it's always the same idea. I'm trying to generate the family of indicators I mentioned before, this life expectancy, health expectancy, lifespan inequality, and healthy lifespan inequality for the different groups that are concerned in these studies. I'm going to go super quick about that and just to try methods. Well, this is perhaps the part where we are still hesitating with my colleagues how to proceed. We started with a very simple method, which is tries to mimic somehow the Sullivan approach, which basically is to start with this healthy survival curve. Let's say we have the survival curve, this L here. And then we multiply it by the proportion of survivors in the population at given age that have good health, right? And we have this L prime here. This is not the derivative, it's just to distinguish it from the other survival curve. And basically we have the classical mortality curve and the morbidity curve. And of course, the areas below these two curves are the life expectancy and the healthy life expectancy. And what I'm interested in all these cases is to look at, at the first differences in these curves, right? This is how the traditional dx's are defined as the differences between the L at hx and hx plus 1. I do exactly the same for this d prime, right? For this adjusted mortality curve or the healthy survival curve. And here I'm trying to illustrate somehow how these two curves would look like. And basically what I'm trying to do is when I have these two different distributions, try to measure how, how dispersed, how variable they are. And for the sake of simplicity, I'm just working with these measures that Alison mentioned, the Gini index. I call G, this is the relative Gini index applied to the age at death distribution, and G prime is the same Gini index, but applied to this age at morbidity onset distribution. Of course, this is an approximation. This is not the reality because all these methods are based on cross-sectional data. So this is a crude simplification of reality. I'm pretty aware that it has to be improved, but at least it's a starting point, and we wanted to play around with different data sets and see what emerged out of these ideas, okay? And yeah, the Gini and the Gini prime are bounded between 0 and 1, denoting the level of inequality. So first, just have very short time, so let's go quickly. Here are some results for the Spanish autonomous community, something I've been doing together with my doctoral student, Octavio Ramajo, he did all the calculations. Basically, here's the 4 autonomous communities that we have been looking at. This is Catalonia, Valencia, Madrid, and Andalusia. These are the 4 more populated autonomous communities in Spain, which add up to 60% of the total population. Data, I don't have much time to spend about it, but basically mortality comes from the INE, and the health data comes from the Spanish National Health Survey. And basically the health indicator is whether individuals had some issues with cardiovascular problems, physical pain, respiratory problems, diabetes, or malignant tumors. Basically, that was how did we distinguish between healthy and unhealthy states. Remember that diagram? These are like the 4 classes of indicators I'm trying to estimate. So basically, I'm trying to replicate this kind of diagram in each of the empirical cases that I have. And this is what I got. Well, I don't have time to go through all of it. There are many numbers, but basically I'm reproducing the previous table for this case for the different autonomous communities. But the main takeaway message here is that these healthy lifespan inequality levels are typically much higher than the levels of lifespan inequality, which is not surprising, but it's something that we should be, start working on and try to understand what's going on behind these trends. Second result, super quick. We've done the same analysis for the whole of Spain, looking by educational attainment groups, together with Jeroen Spijker and Aman Blanes. Again, very quick, the same data as before. Now we're looking at different educational groups. And the results here, again, a whole bunch of numbers. There are many things to see here. I don't have time, but again, the main takeaway message is this one. I mean, healthy lifespan inequality indicators tend to be much larger, or substantially larger than lifespan inequality indicators. And what I think is interesting here, if you look at these educational attainment levels, we have the low, the medium, and the high. Typically, we observe that the lowest educational attainment, the highest the level of healthy lifespan inequality, right? So this is something which goes in line with what has been observed before that Alison was referring to, that low educated individuals tend to have higher lifespan inequality. The same happens with healthy lifespan inequality indicators. It's the same pattern, and it happens in the 4 blocks, right? I mean, typically it goes worse for the low educated in the 4 classes of indicators: life expectancy, health expectancy, lifespan inequality, and healthy lifespan inequality. Third and last study, we did the same kind of analysis across 12 European countries over time, again with Jeroen and Amand. Now, in this case, the definition of health was based on the GALI indicator that was taken from the EU SILC surveys. These are the 12 countries that we took between 2005 and 2015, more or less. And again, there's a lot of information to summarize. These are like the 12 countries moving over time in these diagrams, where I'm comparing life expectancy versus lifespan inequality in the top row. And in the bottom row, I'm comparing health expectancy versus healthy life expectancy. Again, many things to see here. I just have not much time. I just want to highlight again the issue that healthy lifespan inequality tends to be substantially larger than lifespan inequality.
2 minutes,
okay, thank you. That the advantage that women typically have in terms of life expectancy and lifespan inequality tends to disappear when we're looking at healthy lifespan inequality. And when we're looking at changes over time, because here we have the opportunity to look at what's happening in 10 years difference, the movements in these new indicators, in this health expectancy and healthy lifespan inequality indicators, are kind of erratic. I mean, it looks like Brownian motion, I mean, going up and down and here and there. It's not the same as what we observe in the top panel, right? So that's interesting to see. So let me conclude. My impression is that these new healthy lifespan inequality indicators are uncovering new layers of health inequality that are currently not, observable with these lifespan inequality indicators that we're currently using. As I repeated 3 times, this is the 4th time I repeat. The levels of healthy lifespan inequality tend to be substantially larger than the levels of lifespan inequality. For the case of educational attainment, it was interesting to observe that the very clear patterns arise. And in general, the low educated individuals were performing worse in terms of life expectancy, health expectancy, lifespan inequality, and healthy lifespan inequality. So here I'm speaking about this quadruple burden of inequality, somehow echoing a paper I recently read that was picking out the double burden of inequality, because the low educated had lower life expectancy and higher lifespan inequality. Here they're performing bad in 4 dimensions. So this is the quadruple burden in this regard. So my conclusion is that, yeah, these new indicators should be like a nice complement to the currently existing measures. And just to really conclude, let me tell you that all these analyses are based in this, so to say, Sullivan approach. It's not exactly Sullivan, but it's mimicking as much as possible like this framework and try to take advantage of it. But I'm aware of the many limitations of the approach. And in the near future, I mean, to take the evolution over time of cohorts and be able to really check how these age and morbidity onset distributions are measured. And then I stop, and thank you very much. Sorry.
Thank you, Iñaki, for such an interesting and innovative new perspective on adding to this topic of lifespan inequality. Just a couple of thoughts that came to my mind were on a paper recently published by Alison Vandralte and Marilia Nepomuceno, where they show how to decompose healthy life expectancy into that term that is due to the healthy factor and how much is due to mortality changes. I think the same operationalization could be used to compare between healthy lifespan inequalities using one of these stepwise decomposition methods or Hal Caswell's life table experiment. I don't have the name correctly, but life table experiment approach. So definitely something to think. I think I have time to take maybe a couple of questions. One from Fabrizio Culota for you is that Case and Deaton documented the first time this midlife mortality reversal among white non-Hispanics men in the USA in the last years. He asked whether if you find something similar or a similar trend in Spain and or other countries. And Vanessa Dilego thinks that in terms of mortality, maybe lower educated were more heterogeneous, but in terms of health, not necessarily so. Is this maybe connected to the fact that you are considering the age at onset of morbidity and not the prevalences by age? So I guess we have time, a couple of minutes, if you could answer this to go to the break.
Well, okay, thank you, Jose Manuel. First of all, please send me this reference you referred to before about the work by Alison and Marilia. I'm very interested. I was not aware of it, so please send it to me. As regards the issue of whether what we observed in Spain is similar to the US, honestly, I don't know. I'd like to check because I would say that fortunately, the things are not that terrible in Spain as compared in the US because we are observing that all groups are improving longevity, life expectancy and stuff. But if I remember well, the big problem in the US was that this group that you referred to, they were decreasing life expectancy for the first time in many years. So this is something that we are not observing, but it's true that the gap between the highly and the low educated, and so very much in line with what Alison reported in her talk. I mean, we're sort of like this widening gap across trends over time. So I cannot answer that question exactly. And as regards the second question, I don't remember what was it. Sorry.
So it was about whether some of your partners might be driven by the fact that you are considering the age at onset of morbidity and not the prevalences by age.
Well, maybe, I mean, this is pretty much preliminary analysis, and I'm pretty much open to explore new alternatives. And if I might take the opportunity, as Hal did himself, I'm also looking for postdocs who might want to work in this project because we are starting recently, and all these questions are pretty much open because we're starting to experiment on how this could be measured. So I don't really have like an answer right now. We are still trying to find out what would be like the best way to measure this phenomenon. Thank you.
No, that's great. I think this is a new topic that will open new lines of research, and I can see that a lot of students are logged in. So yeah, take notes on these jobs, and get in contact with Hal and Iñaki if you are interested on this topic. Now I will pass the voice to Isaac. How do we proceed, Isaac and Virginia?
Yeah, I think it's best to go on the break. We'll take a 10-minute break. We'll resume with the second session, which Virginia Vazzarulli will moderate. So I think 10 minutes from now exactly, we'll be back. Okay, so people don't leave. We have a second session that looks also very promising. I'll be here just chatting, but anyone is feel free to leave. Iñaki, there are some questions in the Q&A. If you have time to just go through, unless you want to leave, you're not. You don't have to stay here during the break. Okay. But thank you all for your presentations. They were very exciting, and yeah, looking forward to looking like future work of yours, because this seems very, very promising. Okay, I think we're ready to go back. I hope everyone had a bathroom break, made a fresh pot of coffee. Because we're going to turn to the next session, moderated by Virginia. I'll turn it over to you then.
Okay, thank you, Isaac. So welcome back. Welcome back, everybody, to our seminar on new perspectives on lifespan inequality. Can you hear me? Yeah, okay. So the second session, in this second session, we will have, again, 3 super interesting talks and 3 extremely three extremely interesting topics from Fernando Colchero, Michael Engelman, and Dustin Brown. So we start with Fernando Colchero. And we go, if so far we have been talking about methodological aspects, new perspectives, and very big philosophical questions of how to address, not from humans, not humans anymore, at least not only humans, but we in lifespan equality. Colchero is associate professor in statistics at the Department of Mathematics and Computer Science at the Interdisciplinary Center on Population Study at the University of Southern Denmark. His work focuses on developing mathematical models and Bayesian inference methods for demography and population dynamics. And he applies these methods to answer questions related to ecology, evolution, and aging across the tree. So not just humans, also the other species that explores and tries to explain the relationship between life expectancy and lifespan equality among humans and non-human primates. Fernando, please.
Thank you, Virginia, and thank you to you and Jose Manuel and Isaac and Dal for and the rest of the people that organized this seminar. It's been fantastic, and it's a great opportunity. I come from a very different perspective. So although we do analysis on humans, what I will be showing today is using these life expectancy and lifespan equality or inequalities, but to find general trends that we can find not only among humans but also among other species. So let me start sharing my screen. Yes, and I hope you can see that. Let me. Yes, I hope you can see that.
Yes.
Good. So, yeah. So again, and thanks to everyone that is listening. Now, to give you a general idea, what is the thrust of these research topic that I'll be talking about today. Maybe some of you might be familiar with this graph. This is a study that we published in 2016. A big group of people. Some of them are here, like Virginia, and the idea of this study was to find what is the relationship between life expectancy and lifespan equality. And here, lifespan equality is related to the measures that Alison described as a relative type of inequality. So it's in fact the log of the inverse of a measure of inequality, of relative inequality, as Alison described. And one of the take-home messages or maybe the most important take-home message of this paper was that we could find a very strong or very clear linear relationship between life expectancy and lifespan equality among human populations. And this is similar to some of the results that Alison showed with lifespan inequality. Now, we also wanted to explore how this landscape looked like for other species, not only for humans, but also non-human primates. The problem at the time is that we only had one population for each one of the species, so we could just have a general idea. And so one of the caveats of the study, therefore, was that we couldn't really find out if this linearity was reproduced among all the species. And at the same time, and one of the other caveats of the study, or the limitations, although we had some ideas, was that we couldn't really explain why this linear relationship was happening. So what we did is that we put together many different data sets. We invited many researchers that have long-term data sets from the species that we had originally. So not only having humans, but also another 6 species of non-human primates, and being able to see if we could find the same relationship. So we started by, of course, we had to make inferences on age-specific mortality, and To do this, we gather data from 17 different long-term data sets of primate populations in the wild, which is unheard of before. So there's most of the primate studies on longevity are done on just a few populations, very few populations, and this was covering 6 different genera, and then 13 data sets from captivity. We were also interested to see how these related, if we could find the same trend even on captive populations, and we kept 9 of the high mortality populations that we studied in the previous study, just as a comparison with the rest of the primates. So what we did is we use the same methods or very similar methods for inference on age-specific survival. Here the issue is that because these species, for many individuals, you don't know their fate after a certain amount of time, you don't detect them any longer. And it could be just because they might have out-migrated outside of the study population, or because they died. No? So the models that we developed allow us to make inferences not only on survival, but also on the distribution of the ages at out-migration. So we could resolve a bit the problem of the apparent mortality, which is very common on ecological data sets, apparent survival. And what we did, so the rest of the talk is based on focusing on parametric models. And we use the silent mortality model, which you can see here. And the point of using the silent mortality model is that it fits really well most of the primate mortality profiles, age-specific mortality profiles. And the other thing is that its parameters have explained different aspects of the mortality profile. So for example, the blue parameters, the A0 and the A1, they take care of infant mortality. So A1 in particular takes care of how steep is the decline in infant mortality or juvenile mortality. Then the C parameter is what demographers tend to call the age-independent mortality. And then the parameters that govern adult mortality and senescent mortality are the B0 and B1. And the B1 parameter for us was, we were particularly interested on understanding how these affected what we found, because it's analogous to some of the measures that have been taken for aging rates. So we wanted to know how much this parameter did change. So what we managed to fit these models, and we calculated life expectancy and lifespan inequality. Here, life expectancy is just given by E, so I will represent life expectancy with E, and lifespan equality with a symbol epsilon. And again, it's just the log of the inverse of the life table inequality or what sometimes has been called the matrix of Kifid's entropy. And so by plotting then on the x-axis life expectancy, on the y-axis lifespan equality, we managed to actually recover lines in other groups, in other genera at least. And as you can see, for example, in female chimpanzees, the line actually seems to be fairly parallel to the line of the humans. And of course, we have some issues of small sample sizes because we didn't have that many populations. But here the point is that we could actually then take those lines and start exploring what happens, what makes it that we have the lines not only in humans but in other species. What drives these lines? So very quickly, one of the conclusions then, of course, is that there seems to be evidence that there is the same linear trend among non-human primates, which we haven't found in other groups, for example, in plants, etc., etc. Now, of course, because we are very interested in understanding how mortality affects this or which aspects of mortality are affecting these, what we did is first, as a first attempt, we just fixed all of the mortality parameters at the values at the middle of the lines, and then we varied one parameter at a time just to see what happened. Where would that take us on the life expectancy, lifespan equality landscape? And the take-home message from these graphs, these are just the different genera that we explored, is that the infant mortality parameters and the age-independent mortality parameters in general, if you change those, you will be moving very close to the direction of the line, of the genus line. But if you move towards the adult mortality parameters, particularly the B1, if you change that, fixing the rest, it seems that it will push you away from the line. So we wanted to formalize this. So, and the best way to formalize this, and thinking a lot about Hal and Hal's work on sensitivity analysis, is by actually calculating the sensitivities of life expectancy and lifespan equality to changes in mortality parameters. We initially started doing it numerically, but we realized that we could actually derive the sensitivities for any model. So it's not only for the Seidel model, it can be applied to any model. And after some derivations, we managed to come up with an expression for the sensitivity of life expectancy to changes in any mortality parameter, which is given by this integral, where this value S sub theta is just the sensitivity of the survivorship function to changes in a given mortality parameter. So in short, the sensitivity of life expectancy to a mortality parameter is just the total sensitivity of the survivorship function to changes in that parameter. That can be kind of the very general interpretation of that sensitivity. And we also derive the sensitivity of the lifespan equality, which is this expression, which is a bit more complicated to put in more layman's terms. And I have some graphs just at the end of the talk in case people want to look at them. So it's a bit harder to explain. But the advantage of being able to do this is that we can actually calculate precisely what would be the change in life expectancy and lifespan equality for a small change in any given parameter.
5 minutes.
5 minutes already? Okay, good. So what we did here, so we can construct these sensitivity vectors. So, and in short, the sensitivity vectors are just taking that information. This is an example using the chimpanzee line. And what happens if we are right at the middle of the line? What are the sensitivity vectors for each one of the parameters? And this confirms what we found before, which is that a change in the parameters that govern infant mortality or age-independent mortality will shift you more or less along the direction of the line. But particularly for the B1 parameter, a small change in the B1 parameter will actually make you move away from the line to another line, for example. And the other take-home message is the magnitude of these vectors. So the vectors for A0, A1, and B0 are relatively small, but the vectors for C and B1 are huge. So a small change on those parameters, so a small change in C will shift you very far away along the line, and a vector in a small change in B1 will push you very far away from the line. So how we can, so this is just the gradient field, just to show how that relates to the entire landscape. So we wanted to formalize this a bit more, and the idea is, well, we can calculate actually the collinearity of the vectors and see how much they actually move along the line or away from the line. So let's say hypothetically that we have one of the genera that has this C vector, and the C vector here, because it just moves in exactly the same direction as the line, has a collinearity of 1. It's perfectly parallel to the line. And let's say that hypothetically we have that the vector for B1 is perfectly perpendicular to the line. So it will be, the collinearity will be essentially equal to 0. So, and we did this for all of the populations. So this is the same graph on the C panel here, but these box plots show what we found from all the genera that we analyze. And again, it shows what we were thinking we were going to find, which is that the two parameters that govern infant mortality and the age-independent mortality parameter change virtually along the line, while the adult mortality parameters, particularly the B1, are much more on the side on being more towards perpendicular to the regression line, to the genus lines. So now, but what we wanted to know then is, and based on what we found there, is how much actually the parameters are changing. Now we know that the parameters will change along the line, which parameters will change along the line, and which parameters will shift us away from the line. But now we want to know how much the parameters change. And to do that, what we did is actually calculate the sensitivities of the parameters. So we took it the other way around. It's a sensitivity of the parameter to changes in life expectancy and changes in lifespan equality. So by calculating these sensitivities, we construct a similar vector, but now this is the gradient vector for the parameter with respect to changes in these two variables. And in order to calculate how much the amount of change in the parameter, we just need to solve this path integral, which takes into account the gradient vector and, of course, scaled by the rate of the rate of change in the velocity vector, but which needs to be moving along the line. So this is what C is taking care of. So just to illustrate how this works, we have this three-dimensional space here. And we have an axis for lifespan equality, one for life expectancy, and an axis for the sensitivity of the parameter to these two variables.
You have one more minute.
Okay, on the plane, on the genus line, on the plane of life expectancy, lifespan equality, we have the genus line. So let's say that this is our surface of the sensitivities. Well, the path integral is essentially solving the area under the curve that is determined along the line. We did this on log scale, so it was relative, so we could compare the parameters. And at the end, what we found is that essentially what we were expecting. The parameters that change the most along the line are the parameters that take care of infant and juvenile mortality and the age-independent mortality. And particularly the B1 parameter, which takes care of the senescent mortality, changes orders of magnitude less in all of the groups, except for the SHIFACs, which are the extreme case and the least related to humans. So just to quickly conclude, we did find evidence of the same type of linear relationship. We found that these lines were mostly driven by changes in infant mortality and age-independent mortality, and that the adult mortality parameters, particularly the B1, changed much less in comparison to the other parameters. And of course, one could imagine that if you change a lot the B1, then you will swap from being, let's say, a chimpanzee to becoming a baboon or something like that. So it will move you away from your line. And yeah, so these results support to some extent this notion that the aging rates varies very little within species, between populations of the same species. And it gives us an idea on how that is happening. So I just quickly, before I finish, I want to thank all of my collaborators, some of which are there, like Jose Manuel. And again, thank you very much for listening, and I'll be happy to take questions.
Thank you, Fernando. Thank you. Very, very interesting talk and about this, biological roots of the rate of aging. Very, very interesting. So if there are questions, yes, I think we have time for one, two possible short questions. So Fabrizio Culotta asks, your model assumes interdependence of parameters in theta. If this assumption is relevant, maybe for mathematical tractability, would you test it?
Well, let me see if I answer this correctly. I don't think we're assuming that. Actually, the lack of independence between the parameters is actually given by how they change along the lines. So all of the parameters change along the lines. So when we do these tests, we take into account the changes in all parameters, not only that specific parameter. The first time we did it, just to have an idea, we did fix all of the rest of the parameters, so assuming that the parameters were independent, but not the way we did it to calculate the path integrals, etc., because along the line, each one of the parameters is changing. So those need to be taken into account, and those modify, of course, life expectancy, lifespan equality. I don't know if that answers the question.
Okay, thank you very much. I think we move to the, thank you, Fernando. Thank you thank you for the questions. So we move to the next presentation. Our next speaker is Michael of Sociology at the University of Wisconsin-Madison. She is Director of Training at the Center for Demography of Health and Aging and recently became Director of the Wisconsin Longitudinal Study. Her research examines the dynamics of population aging and health across the life course and tries to bring together perspective and methods from formal demography, social science, public health. Her research explores also the variation masked by aggregate population statistics and the links between social stratification and the health inequality in later life. Today, she's presenting some of her new work in progress that aims at linking mortality inequalities with health and health disparities in older populations. So thank you, Michal. The floor is yours.
Thank you. Thank you. Let me see if I can share this the right way. All right. Can everyone see this? All right.
Yes.
All right.
Please go ahead.
Great. Thank you. Yeah, so as Virginia said, what I will be talking to you today is about some new work in progress. So it builds on some earlier work that I've done on lifespan inequalities, and I think tries to move a little bit in the direction that that Hal was talking to us about earlier, about thinking about the implications of sort of the relationship between variation and variability in mortality and risks for other domains in health. And so just make sure, can I move this? Oh, sorry. All right, hopefully that's better. So first, I'm just going to start with these figures that are hopefully familiar to everyone. This is the distribution of ages at death in the United States in particular. And so I think we all know that the distribution has changed over time, with deaths becoming more concentrated at older ages. And we can see, if we look at these conditional variation measures, right, along the lines that that Alison talks about before, that variation in lifespan inequality overall has gone down. These data end in 2016 because that's also when the health and retirement study data that I'm using end. Unfortunately, the same reason that makes us meet on Zoom today rather than in person also probably means that trends might look quite different if we look at more recent data. But for the time period under consideration here, what you can see is that lifespan inequality overall in the United States was declining as life expectancy was increasing. But if you look at survivors to older ages, if you use some of these conditional variations of lifespan, you can see a little bit of a hint here, right, that it seems to be increasing. And so hang on a second, sorry. I originally made some of these figures a long time ago when I was writing my dissertation on Swedish data, but these are some contour plots that look at similar patterns for US data over the time period. And so it shows us that if we look at the ratio, right, is lifespan inequality conditional on some age, the age is on the y-axis, when you look at it over time relative to when it was starting to be measured, is that variation increasing or decreasing? So you can see a little bit more clearly the pattern from before that suggests that there is overall, even as overall lifespan inequality is declining, the variation conditional on survival at older ages is increasing, right? So that suggests that partially this is driven by more people surviving to older ages, because we've done a good job as a society of reducing mortality in early childhood and in infancy, but that once people arrive at some threshold of age, there is more variation, more uncertainty about lifespan inequality. And I'm interested in sort of this idea that, right, that the stochasticity here is maybe not as central to questions of understanding inequality as Hal suggested, as what is driving those underlying mortality rates that is related more to inequality overall. What are we seeing? And in particular, I'm also interested in what is the fact that lifespan inequality has grown more variable for people who survive to older ages. How might how might that be related to health, to patterns of health and what we might expect in terms of the health of the older population? And so this relationship between mortality and health seems pretty straightforward. But I think it's a little trickier, right? So for individuals, we usually think about old age mortality coming after some kind of period of health decline. But from a population perspective, when we think about cohorts, it is also the case, right? Unlike for people, that the mortality patterns at younger ages shape the patterns of survival and also potentially of health at older ages, right? So in that sense, when we look at patterns of health in later life and we think about whether there is inequality and variation there, we have to remember that mortality is also a competing risk to the development of particular health conditions or impairments. And so when we try to compare across population, right? So folks on this and this webinar and elsewhere have been very interested in thinking about variation along dimensions like educational attainment and race and ethnicity in particular in the United States, right? And so when we think about variation in health at older ages across those groups, we also have to make sure we really remember that this variability in mortality may have implications for how we understand that. And so the work that I'm going to show you today draws on kind of two theoretical frameworks from sociology and sort of life course studies, right? So first is just this idea of cumulative disadvantage, right? Which is a sociological theory that assumes or that sort of argues, right? That existing social disadvantage, right? In social and economic and health domains accumulates and interacts over time, right? So people who sort of are advantaged tend to sort of maintain that advantage and maybe even increase it over time, and people who are disadvantaged can accumulate disadvantages over time as well. And this theory originally was applied to things like sort of occupational success and people's career trajectories, and people increasingly are also applying it to understand health trajectories. And it assumes, right, that people who are exposed to things like racial segregation and discrimination and concentrated poverty are going to sort of ongoingly accumulate those exposures, and that those are going to be manifested in increased inequality in health and in mortality over the life course. And then on the other hand, there is a framework of punctuated equilibrium, which Heidi Jackson, who was a student of mine and is now at the Population Center at the University of Maryland, have done a lot of work on, which points out that health at older ages is, often thought of as just kind of following this cumulative disadvantage pattern. So we will see more inequality in health. But when you actually look at trends in health over time, if you have longitudinal data, you notice that people don't necessarily just constantly sort of get worse in terms of health. In fact, for most people, trajectories of health kind of look like this. I'm going to skip ahead a little bit, right? So there's a lot of stability, right? Kind of a homeostasis, and then intermittently there's changes. And sometimes those changes are in a negative direction, which means you accumulate more health problems. Sometimes they're in a positive direction because people get better, right? People's health improves. And actually, most often when we look at longitudinal data from the Health and Retirement Study, which is a national sample in the US, most of the time what you see is kind of no change. There's a lot of stability and just these kind of occasional patterns, right, that happen kind of non-linearly and in different time. And so change is rarely continuous and gradual. It sort of just is very heterogeneous. Even if you sort of, and often in the data, and this brings us back to the relationship with mortality inequality, the data that we are able to observe on death is punctuated by people dying or being lost to follow-up in the study. And so even if we sort of say, well, let's look at people who have seen some kind of worse health or some kind of decline in health and take that out, you can still see that this punctuated equilibrium pattern holds, right? That most of the time things are kind of static until there's a change in one direction. And so based on that, the questions that we are interested in asking is, in keeping in mind this idea both of cumulative disadvantage, but also the fact that individual health trajectories are characterized by this punctuated equilibrium pattern, is whether people who enter life in poor health are at greater risk of experiencing subsequent health decline. And I'm going to preview things here by saying that, mortality turns out to really complicate that. So inequalities in mortality have implications for whether we observe the inequality that we might expect in health. And we're also starting to look at whether markers of exposure to disadvantage earlier in the life course are associated with these health changes in later life, kind of along the way that cumulative disadvantage frameworks propose, right? And so the data, like I said, come from the health and retirement study. And in particular, what I'm going to show you is data that looks at the relationship between sort of people's mortality experiences and health, which we measure by looking at a sum of functional limitations over the multiple waves of the study, right? So people in the HRS are interviewed every 2 years, and then we look for each year, whether they report having no difficulty or some difficulty performing these varieties of tasks, right? So really trying to figure out kind of people's ability to function. And so the punctuated equilibrium, sorry, 5. Okay. The punctuated equilibrium perspective suggests that, we kind of want to look not at a smooth parametric pattern of health change, but rather at kind of more discrete outcomes, right, of whether people experience change and in what directions, and that we really want to look at what happens at the impact of people dying or dropping out of the study to our ability to understand patterns of health change, and specifically inequality in those patterns of health change. And so in the interest of time, I'm going to sort of just rush through it, but say that so we're going to look at I'm going to show you just some very basic descriptive statistics that I think are still suggestive, and then some multinomial regression results, right? And so basically one thing to note, if you just look at the characteristics at baseline of this sample that is, like I said, nationally representative and one of the most commonly used ones in analyses of health and health disparities for older population in the United States, you can see that the starting health of individuals at around age 50 varies by race as well as gender, and that while white and Black women are underrepresented in the no limitations category and overrepresented in the high limitations category relative to their share in the total sample, and white men, in contrast, are overrepresented in the no limitations category and underrepresented in higher limitations categories, right? And then if you look at it by education, right? And I should also say that the Black men are overrepresented at both tails, both sort of no limitations and a lot. And then as predicted, as what you might expect from cumulative disadvantage theory, people with social disadvantage, so those with social advantages, those with higher levels of education and those who are married, which we use as an indicator of having a lot of social support, are more likely to start the survey with few or no functional limitations, right? And others are more likely to start with more. So that suggests that social disadvantages in early life are associated with health at midlife, just like you would expect, right? But the health pattern is actually less intuitive, right? And so most people who start out with no limitations are actually more likely to report a decline in health or accumulation of functional limitations later on, whereas those who start off at the worst health or have the most functional limitations are also likely to accumulate additional impairments, but they'll report sort of fewer of those relative to people more, right? And then also, I should note that health improvement, a decrease in impairment, is also very common, right? So about 71% of the full sample will experience improvement health, right? But at the same time, so you have these kind of counterintuitive associations with improvement in health and decline, but the relationship with mortality is much clearer, right? It is more sort of positively associated and strongly linked with mortality, right? So those who start the survey with no limitations die during follow-up, like at a rate of about 27%, but the rate is close to 60%, 59% for those who start with a higher number of limitation, right? And so what this means is that over time, the people who stay in the HRS and who allow us to learn more about patterns of health and health inequality in later ages, that's actually associated with having exposure to a lot more disadvantage in early life. Right? And these differences matter by race and by gender. So white women are more likely to remain in the survey and to be at the same health or with more limitations than they are to be lost to mortality. But white men, Black men, and Black women are all overrepresented among people who are lost to mortality, right? Because of this higher mortality rate in these populations. And so that means that our understanding of health declines in later life are disproportionately informed by the experience of relatively advantaged adults, in the sense that these are the people who don't die, right? So it's not accounting for that increased mortality early on, right?
You have one more minute.
Allowing us to see it. Okay, so I'll quickly try to say that, basically what we are showing is that advantaged health status in midlife seems to increase the risk of subsequent health declines, right? And so for all the groups, except for Black men, the number of functional limitations at baseline, it means you're sort of less likely to accumulate limitations later, right? And that, excuse me, starting with a health advantage actually increases your risk of acquiring more impairments, but decreases the chance of mortality, right? So what this suggests, right, is paradoxically, unlike with mortality, where it's really clear that mortality is bad, survival is good, a higher number of functional limitations or poorer health in later life seems to be a marker of a longevity advantage in later life, right? You have to survive long enough in order to develop these health inequalities, right? And so it suggests that exposure to social inequality shapes later life health inequities, and the fact that we sometimes see fewer racial disparities or fewer economic educational and economic disparities in health in later life, mostly because these exposures to disadvantage are acting on mortality and changing the composition of the cohort that is surviving to later life. And so in particular, right, that means that if we recognize that survival itself is a marker of advantage, not just of outcome, and earlier mortality is sort of, as was said before, kind of the ultimate disadvantage because all other things are dependent on it, we can more clearly link the factors that shape lifespan inequality with the inequalities that we later observe in health throughout the life course.
Thank you, Mikael. Thank you very much. I think your presentation gave us interesting inputs also to think about the male-female survival paradox. All these females who survive long enough in the surveys are females, while you said males most that to survive. I mean, in order to make it to older ages and in order to develop those health conditions, you actually have some sort of survival in longevity, which is what we know about the male-female survival paradox. If there are no questions, I would move on to the next presentation to be on time with the schedule. If there is, I don't see at the moment questions. So yes, I would just move to the next speaker. Dustin Brown. So Dustin Brown is assistant professor of sociology and research fellow at the Social Science Research Wing at the University of Michigan Population Studies Center. He's a social demographer, and his research interests are mostly in population health, aging, and the life course, and social stratification. In his research, he examines the effect of social inequality and social relationships on adult health outcomes. His recent research is mostly focusing on educational and marital status differences in morbidity, disability, and mortality risk among older adults. So, Dustin, Thank you very much for this presentation. The floor is yours.
So while I'm getting this set up, can you all hear me? Everything all right? Okay.
Yes.
Great.
Yes.
So start the slideshow. So yeah, thank you for having us present our work here. What I have to say about this, this is a longer term project.
Dustin, I'm sorry to interrupt, but we're seeing your notes or your next slide as well. Do you want to?
That's weird. Okay, so I have two screens, so maybe that's what's happening here. So I'll just do this. Does that work all right?
I will say yes. Yes.
Okay, great. Here, this is part of a longer term project that's really focused on kind of a first step. This is largely descriptive, but this is the first step in a longer term project kind of to examine the subnational trends and differences in lifespan variability or lifespan inequality in the United States. So this is with my colleagues at the University of Memphis, Joseph Flaherty, and Benjamin Walker, who is here also at Mississippi State University. So a little bit of background. Geographic disparities in population health is there's a growing emphasis on this, especially in the United States, and I know elsewhere too. So in the US at least, disparities exist at multiple spatial levels, but states are of particular concern. And I'll talk a little bit about why that is here in a second, but you can see these kind of geographic disparities that have actually grown over time. At the county level, at this, neighborhood level, city level, whatever level you look at, but really states are really what we're focusing on here for a couple of good reasons. So just kind of give you an idea of what I'm talking about here in terms of these disparities. This is from the US Mortality Database. So in 2017, life expectancy ranged from, this is in the United States, ranged from a high of 81.6 years in Hawaii, in the state of Hawaii, to 74.6 years in West Virginia. So within the United States, you see just wild differences in the amount of how long people live. And then you see the same kinds of patterns for other health outcomes, disability, healthy life expectancy, what have you. Like any kind of health measure, you're going to see these kind of big time kind of spatial and geographic differences in the United States. And there's this growing divergence in population health between states, like I mentioned before, since at least the 1980s, really kind of before that a little bit, but really kind of accelerated in the 1980s. And that's where the policy environment kind of comes into play, we think. So the state policy environment really, really matters. This comes from work by Montez and colleagues and Jason Beckfield, some other folks in the United States, who have looked at kind of how state policies shape population health outcomes. So things like disability, healthy life expectancy, and other things as well. There's been work on smoking and obesity and kind of general kind of population health work. So why is that? So to kind of give you an idea of why that is for people who aren't as familiar with the US system, the federal government increasingly has ceded regulatory power and policy decision-making to state governments. So what that means is states have a lot more latitude to kind of implement and design programs in different ways. So the one way to think about this is it's going to end up in wide state level variation in social and economic and health policy environments. So one way to think about this is you have policy X and the federal government would say you need to do these kind of things, but you have a lot of different ways to kind of accomplish that goal or kind of meet that standard. And basically some states are better at implementing those standards than others. So states make different decisions. So one way to think about this is we were kind of thinking about this, and again, this is kind of work in progress in some ways. This first study is very descriptive, but we're kind of laying the groundwork for more, for later research that kind of focuses on these things we'll talk about here in a second. One way to think about this is states are really kind of, US states are kind of akin to semi-autonomous kind of geopolitical and economic units in the United States. So there's kind of this loose patchwork. There's kind of a superstructure that binds them together, but it increasingly is a situation where states kind of choose their own adventure, for lack of a better word, in terms of how they implement policies, and that matters. So the policy environment matters because there's been a lot of talk in previous research and in previous presentations here in the seminar or in the webinar on the importance of kind of compositional differences, and that's this last point on this slide. So there's also a lot of state-level heterogeneity in demographic composition, so education, racial profiles, health profiles, smoking rates, those kind of things. That stuff also matters, but that stuff kind of doesn't play out kind of in a social and economic and kind of political vacuum. So what's happening is the state context is shaping the constraints under which people can kind of exercise and kind of maximize their potential to kind of use those resources in different ways. So for example, we know that in the United States, education matters for health. It's kind of the case everywhere, but we know that education matters more or less depending on the state you live in. And that kind of links back for health and mortality risk. In terms of the education gap in mortality or health, and that kind of goes back to these kind of state contexts. So one kind of simple example would be, if you have a heart attack in a state that has a lot of high intensity kind of, excellent healthcare services, you're going to get to the hospital, you're going to probably be taken care of, right? If you're in a place that's really rural, there's lots of distance between places, like in the state I currently live in Mississippi, you might not make it because you're just not going to get to the hospital, right? It doesn't matter how much education you have, you're not going to be close to a hospital, right? So things like that matter, and that's not necessarily policy environment, but it shows you kind of one mechanism, at least, in how these kind of disparities can kind of come about. So in the United States, we've seen this, as other people have kind of alluded to in here in the webinar, we've seen a slowdown or even reversal in progress in increasing life expectancy, and that is really alarming, and it's kind of not what's kind of supposed to happen, right? Life expectancy is a commonly used measure of between group inequality, so it's the average age of death or some other kind of central moment, right, in a distribution. But life expectancy provides less information about within group inequality, and as you all know, that's where variability in the age of death or inequality in the age of death kind of comes up, right? That's why we need to look at both the center of the distribution, but how much dispersion there is in the distribution of age of death. So stagnation may also extend to variation in age of death around the average age of death, and we know that, so we're kind of looking at that here. So we have 4 goals here, and we're not going to talk about some of this stuff here, but just kind of lay out. Again, this is very descriptive. So we're going to describe trends in lifespan inequality for the U.S. overall, describe trends in inequality by state. Then we're going to kind of do just a simple kind of ranking of states and kind of compare their position in the first period that we look at in 1960-64 with their position in the last period in 2014. And then we're not going to talk about this, but I'll summarize the results. We've begun decomposing the trends in lifespan inequality by age, and we'll talk a little bit about that. So I'm not going to belabor this, but basically the data come from the Human Mortality Database, or the U.S. Mortality Database, I guess, from 1960 to 2014. We've done some analyses with the more recent data that's been released earlier this month, and it's basically the same result. So, it's basically the same. We have single year age of death from ages 0 to 110. And then we have 5-year periods from 1960 to 2014. We use 5-year periods for 2 reasons. One, it just increases the stability over time, and we've done it with single years too. It's the same result. Just the figure's a lot more busy, right? So that's why we kind of done this to kind of smooth things out. That's the part about it, facilitating interpretation. And then we've done this for the total population in sex-specific analyses. We don't really show the sex-specific analyses very much here, but basically the general patterns hold for both men and women. Our measure, and I have this, it's funny, as Alison pointed out, these measures are all correlated, and every day has here too, but they're not necessarily interchangeable, right? So I'm guilty of saying that they're kind of, they're kind of measuring the same thing, when, well, really, as Alison showed us a second ago, that's not really the case. But we're looking at lifespan disparity. I'm not going to kind of really belabor this either, but it's interpreted as the average years of life lost, basically. So the idea here is the number, EDAGR is correlated with other lifespan inequality measures. And how do you interpret this? Low values indicate less inequality in age of death, and higher values mean more inequality, right? So it's kind of the normal interpretation here. So to show you this picture, this figure that is very similar to the one Mikhail just showed you for the U.S. is from the same data source. So you see this general process when infant mortality has kind of reduced over time. These are the DX curves from the life table, so the life table age of death. And what you see is over time it's shifted to the right? So people are living longer. The modal age is higher than it used to be in the past, which correlates with life expectancy as well. And then you see there's less variability in the age at which people die. And you can see this, for the US as a whole. You can see this between race ethnic groups. You can see it within educational groups. You can see it between occupational groups. This is something you kind of see across the board. But you can see there's been a long-term trend toward both mortality, increased life expectancy, even though it's not really shown here, this implies that, and less variability, basically. So here is the first picture for the United States for lifespan disparity in the United States. So this is the EDAGR measure. And what you see is exactly kind of what that picture showed. Over time, there's been periods of stagnation. There's been periods of kind of steeper declines than others. But basically, overall, the overall trend is down, which is what you want, right? So that means there's less inequality over time in lifespan disparity. So that's a good thing. I think we can all agree. This is for the overall population or the total population, but you see the same thing for men and women. This red line with the dots is men, this is women. And so basically it's the same general pattern, but it's just different scales, right? And we know that because there's female differences in life expectancy and mortality.
5 minutes.
Okay.
You have 5.
So this is the same thing for lifespan disparity by state. So just to give you a primer on what this means, the diamonds are the US average, and then all these dots are individual states, right? This one up here is a little bit different. This is Washington, D.C., which technically is not a state. It's a large metropolitan city, basically, but we include that in here because it's in the data set. So we're going to focus on a couple different scenarios. So this is for the state I currently live in Mississippi. What you see here is that Mississippi has the highest or among the highest levels of lifespan inequality or lifespan disparity in all periods, right? So basically this group is kind of one way to kind of borrow language used in other studies on similar topics. Mississippi is definitely kind of a laggard, right, in terms of their ability to kind of reduce lifespan inequality. And then, this blue, again, this is always this blue, this is the United States, and the circles are going to be, the red circles are going to be the individual states. By contrast, if you look at Minnesota, which is another state that consistently has the best levels, not best levels, but has the best kind of profile in terms of lifespan inequality, it's the total opposite situation. So, if you were to look at this, take a step back, you wouldn't even really think that these are kind of in the same country, but they're regions in the same country, right? And a lot of this probably has to do with a lot of reasons, but one we think is policy differences. So to summarize the results here, the contrast is really stark, right? So to kind of put a finer point on it, in 1960, there was about a 3-year gap in lifespan disparity. So you just subtract the lifespan disparity for each state from one another, right? In 2010, 2014, there's still about a 2-year, almost 2.5-year gap. So basically what it's saying is the overall trend is downward, but the difference is the disparities haven't converged, right? So you're seeing this kind of parallel lines almost in some ways. In Mississippi, now in 2014 actually has higher levels of lifespan inequality than Minnesota did almost 6 decades earlier. So that's pretty incredible to think about, right? So, you were seeing this play out in different states. So the key point here is that levels of lifespan inequality differ substantially between states despite a downward trend for the US overall. So I'll kind of skip over these, but there are states that California's a state where they've kind of had they basically were kind of middle of the pack and they ended up doing better than the US overall. Well, I can talk a little bit about that here in a second. Ohio's kind of the opposite situation. They've kind of had a reversal of fortune. So they start off lower than the US overall, and then by the end period, they're kind of taking up and they're actually higher than the US overall. That's not what they're kind of California's moving, one way to think about it is moving kind of in the right direction. And Ohio and other Rust Belt states are moving in the wrong direction. So what does that mean? And the reason I'm skipping over this is because you see this. So here what we see, this is the ranking information. So Minnesota started off at the best in the nation in terms of the most favorable environment for the least amount of lifespan inequality. And they ended up, if you just compare the first and last period, they're still there, right? And you have a couple states that do this, and I'm not going to kind of go through individual states. This is Minnesota, but I can talk about that later on. Then you have the laggards, right? Mississippi's at the bottom of the barrel. It's always in the bottom of the barrel. It's right here. But what you see is there's geographic clustering here, right? This is the southeastern United States. This is New Mexico, which is another very poor state in terms of economic levels. And then this is, Wyoming is kind of this interesting anomaly, but it's there and it's kind of not doing so hot either. Then you have places that have notable improvements. This would include places like California here, or Texas and Virginia. And you see that basically they've gotten reduced lifespan inequality over time, right? They've gotten better, which is what you want to happen. So that's kind of a success story. And then, but you have places that have kind of deteriorated.
You have one more minute.
All right. A lot of these cluster in what we call the Rust Belt in the United States. So these are places that have suffered a lot of problems, but deindustrialization, things like that. So the the labor market conditions there aren't as favorable as they once were. Contrasted with a place like California, where you have kind of the rise of the technology sector and kind of Silicon Valley, prevailing labor market conditions there have, among other things, have gotten better, right? So what does this mean? In summary, lifespan inequality decreased in the United States between 1960 and 2014, but there's a lot of state level heterogeneity. We observe both change and persistence of advantage or disadvantage in lifespan inequality. And these general patterns, by the way, are not just for the total population. You see it in men and women. While we didn't show this, and this kind of comports with previous research and some of the research that's been shown today, infant mortality is a big driver of this. States like Mississippi have been just less successful at reducing infant mortality than other states. An uptick in these kind of like so-called deaths of despair, kind of midlife mortality seems to matter, but that's more in the later period. So when you look at the period from 1990 on, or 2000 on, the midlife and young adulthood mortality kind of increases are worrying and reason for concern, but that's really not happening until more recently. It's really about reductions in infant mortality, and infant mortality still matters across the board. So the last thing I'll say here is that these patterns uncovered are likely tied to state policy environment. And the last point here feeds into kind of what a lot of people said today in terms of methodological stuff and other things. Substantively, what this means is we have to take a step back and kind of think about this carefully. Just as life expectancy and lifespan variability measures aren't interchangeable, it doesn't mean that the policies that affect each of these things are interchangeable. So what does that mean? It means that just because policy X increases life expectancy, it might not reduce lifespan variability, or it could actually exacerbate the situation. You're going to have widening variability. And there's kind of hints at that if you look historically in the United States, which we've seen these kind of periods of stagnation and kind of what people deem kind of the shifting mortality scenario, where you have, say, a mode or a life expectancy is increasing, but the distribution of deaths around that central moment aren't really changing. Like the distribution just kind of moves over, right? And that could be because of this. So that's, thank you for your time. And
thank you.
Thanks.
Thank you. Thank you, Dustin. Thank you very much. We have 1 minute for one question, if there is some question from the audience. Otherwise, I would say that we can. So thank you very much, first of all, to the 3 speakers of this second session. We really went from the animal kingdom to health, epidemiological and health transition to state level policy. So I think this shows, together with the talks of the first session, this shows how interdisciplinary and wide the topic of lifespan inequality is. It really touches the interests of pretty much everybody dealing with organisms living in some sort of social setting. Not just humans. So if there are no, there is a question. So I would take this question, and then I would go to the next phase of our webinar, which is the open discussion. So a question for Dustin: have you looked at the relationship between lifespan disparity and life expectancy in the States? I imagine this would be really interesting to see as well.
Yeah, we actually have. So that's some of the figures that I didn't show, right? We have a couple of those. We've done more work on this, but what other people have shown is that in countries as a whole, is that the two are really closely related, and we've seen some of that today as well. But in the U.S., there's a paper by Valpel, and I believe Alison was part of this project as well, that shows that in the U.S., like in many respects, unfortunately, is an outlier. And what you see is that the correlation between life expectancy and lifespan inequality, whatever the measure, isn't as tight, basically, in the United States. So there's kind of they're not as tightly correlated, but they are highly correlated. So what does that mean? At the state level, that suggests that you're having this kind of disconnect between the two measures. It kind of suggests that, you know, it has implications for those kind of shifting versus compression kind of scenarios, right? If things are compressing, you should see an increase in the central moment, life expectancy, mode, whatever, and you see less variability. So it kind of maps on sort of with what we saw here with these periods of kind of stagnation in E-Dagger. So that's probably what's going on. But yeah, they definitely kind of, the short answer to that is they are correlated. But in the U.S. as a whole, they're not super correlated, and then you see the same thing in U.S. states. A lot of heterogeneity. I guess the word of the day is heterogeneity, right, in the United States.
Thank you, Dustin. So
I have a quick question for Dustin, if I can.
Yes.
Yeah. So it would be very interesting to see what happened after 2014, following the, you know, like this potentially higher mortality in midlife in some states. Just to reflect a little bit, in Mexico, what we found is that in those states where midlife mortality is very high due to homicides, for example, you have the reverse relationship. So life expectancy can increase together with lifespan inequality, which also is in line with Alison and Isaac's findings for lower socio, and Iñaki's findings with lower socioeconomic findings. Just a comment.
Yeah, so that's a good point. So we just didn't have time to kind of do everything with the 2018 data because it was corrected and then re-released earlier this month in the U.S. mortality database. I can say that we've done a few, not complete, we're still working on it, but some analyses. And what you see is that exactly what you're saying, kind of, if you would kind of draw a line on the end of those trends for 2014, what you basically see is that if a place like Ohio is decompressing, right? If lifespan variability or inequality, E-Dagger is increasing, it's kind of that, unfortunately, that trend is kind of continuing. And then for other places like California, it might be stagnating or might even be kind of going down more. So I think that's really important to look at the most recent data, and we are working on that. It's just, we just didn't have a chance to do it yet. And of course, COVID is the other wild card, right? I mean, that's going to make everything kind of go haywire when those data are actually released.
Thank you. So Isaac, how do we proceed? Do we open the discussion, which I think we already have more or less?
Yeah, I think we can open it. I'm not sure
Yeah.
we have the ability to let the attendees use their microphone in this format. That's one of the downsides of the webinar. But we can have questions in the chat, in the Q&A, and then turn them over to the speakers.
Okay, yes. So if there are any questions, again, more questions from the participants, please type them in the chat.
Yeah, I see there's a question for Dustin.
Oh yeah, I can see. So do I take it? Yes, okay, for Dustin. Actually, there are two questions for Dustin still. So are there specific determinants, policies / risk factors identified that improve overall life expectancy, but also increase variability? Such some sort of policy paradox. And Dustin, do you want to answer one by one, or do I rather kind of collect them all? Because these are both for you.
Let's go ahead and say the other one. I'll address them one by one, but that way, yeah. So what's the other one?
Okay, and then the other one is considering an observation that was made earlier this morning that people are startling.
Virginia, you're breaking up a little bit. Well, it says considering an observation that was made earlier this morning, that people's own perception of the uncertainty matches their actual situation. The political implications of results are startling. So I think it's more like a comment than a question, actually.
So sure, so I'll take the first question first. So the policy paradox, right now, I'm not sure about specific policies that kind of result in this kind of paradox where one thing goes one way, the other thing goes the other way, right? So basically you increase life expectancy and lifespan variability doesn't also decrease. Part of that's going to be kind of contingent, I guess, on kind of the interrelationship between these two measures over time, right? So which one starts moving first, right? And it's kind of, you got to kind of figure that out first, I guess, to kind of know what's happening there. But in terms of the specific kinds of policies, other research on life expectancy, at least, and other health outcomes, disability, healthy life expectancy, has started looking at certain things. So we know, for instance, that a tendency toward kind of deregulation generally, those kind of things in kind of more conservative political environments are kind of correlated with worsening life expectancy. And that's not necessarily for political reasons, but it has to do with kind of regulatory environments and the kinds of policies that are put in place. So like things like excise taxes on tobacco to reduce smoking, things like that. In a place that has a more conservative political environment, they're less likely to enact those kind of policies, right? And that's going to have an effect on smoking rates, and then eventually that's going to translate into some health outcome, right? And then there are other things too. There's just differences in kind of regulatory environments, not necessarily just focused on health. It could be like educational regulations and kind of how education or kind of labor market stuff is done, or it could be tax policies, or, you know, in the United States, it could be, there's a lot of research to show that expanding, when we had healthcare reform during the Obama administration, one piece of that was efforts to expand insurance coverage, federal insurance coverage to other people through Medicaid, one of our social insurance programs. And we know that states that expanded Medicaid have lower rate, it is, you know, associated with lower rates of infant mortality and those kind of things. So that stuff's going to feed into lifespan disparity as well. And then that kind of perception versus reality thing is kind of interesting. I think if I understood the question, I might not have fully understood the question. It seems like the question is really about, you know, the differences in kind of how people perceive what's going on versus what's actually happening. And I think that that's really interesting, and people kind of have an idea, but there's kind of this underlying that assumption. It assumes that even if people kind of know that doing X, Y, Z, let's say smoking, it assumes that the decision to smoke is a completely rational decision, and it's not necessarily that way, right? So the rationality kind of has constraints on it. So it's not like if you feed a person this kind of information, they're going to modify their behavior accordingly. Well, maybe, maybe not. And that kind of, and interestingly, that's where kind of those kind of economic and kind of social constraints kind of come in. So that stuff kind of plays out in different contexts. On one context, that stuff can kind of play out as these kind of real kind of policy contexts that differ between states, basically. I'm not saying that very well, but.
Okay, I'm sorry to interrupt, Dustin, but we can open now the attendees' microphones. So I'm gonna, we have a question from Michal, from Ridhi Kashyap.
And then Hal also wants to have some intervention.
And there was also a question earlier on in the.
Okay, but let's take the question from Ridhi. Do you want to talk on the microphone, Ridhi?
Hi, sure. Can I be heard?
Yes.
Great.
Yes, yes.
Yeah, thanks to the organizers. This has been a really stimulating webinar. I really enjoyed it. And thanks to all the speakers as well. Excellent talks. My question to Michal Engelmann was about the mortality selection idea, which I agree is, I mean, clearly very relevant for what we observe in the survey in the HRS. But I guess my question is, how do we think about, and how can we explicitly incorporate this idea of mortality selection, which clearly has these implications for what we observe, into analyses sort of concretely? And also, do you think this is something that just matters for research, or do you think it also has implications for policy? I mean, one way to read this could be that we should focus more on mortality inequalities than, for example, aging trajectories instead. Is that you think a fair assessment of one policy implication of this?
Thank you, Rini. These are really, really great, great questions, great points. So I think, you know, first on the issue of kind of methodologically of what this means for analyses, I think maybe the implications I have is that that it's the people who are focusing on analyses of health in later life that that need to pay more attention to mortality, right? And so really this is methodologically, I think this speaks to the idea that lifespan variability has often been kind of siloed off with with formal demographers, and then public health researchers often are focusing on analyses of health outcomes, and sometimes they have data that's linked to mortality, and sometimes they don't. But the methodological comment there is really that any analyses of longitudinal patterns of health have to consider mortality as a competing risk, whether they do that, sort of formally by models that incorporate survival analysis with longitudinal methods, or whether they go kind of instead of parametric long-term trajectories with like maximum likelihood models that only consider information as it's available, but don't necessarily account for the fact that there's systematic selection and who is providing more information rather than less. And so yeah, I definitely think that the methodological implications is that this mortality pattern can't be thought of as existing separately than patterns of health in later life. And then the second question about policy, I really like that question. It's something I think a lot about what are the ultimate implications on all of this. And I think, the answer is sort of twofold. One is just to realize that if what we are interested in is health equity in later life, that the usual type of policy, and actually also kind of program and medical interventions that are really focused on maybe slowing down the pace of health decline, right? So how to help people once they've already started that trajectory of health decline are useful for those people, right? They're useful interventions for individuals, but as far as something that deals with inequality or an inequity, they're not sufficient for that, because they're primarily benefiting the relatively select group of survivors who are sort of the most robust, least frail group of individuals, right? And so a longer term strategy for promoting equity in later life health means that the interventions have to go beyond the sort of proximate, like how do we help someone who's starting to sort of have mobility difficulties move better and so forth. So beyond these kind of very proximate determinants that often get treated with sort of medication or assistive technology, and those things, that it is incumbent on people who care about inequity to also think about the fundamental causes of earlier mortality, right? And so fuller equity would mean that we need to invest resources in things that will improve survival. But paradoxically, I think that what that would end up doing is improved survival might actually increase disparities in health in later life, because you're going to have more people surviving into later life, right? All of which is to say that doesn't mean that we shouldn't continue to help people in later life and sort of focus on things that improve the health trajectories later on, but rather that doing only that will help those who are already most advantaged and won't necessarily address the equity. So for equity, you basically have to do more.
Okay, we have a few more questions. Actually, I have a question for Hal, and then we have Fabrizio. Maybe this is for the entire panel. So I will start with my own question to Hal. I'm very sympathetic to your argument, but I'm wondering how much of this is a critique of lifespan inequality research or social science more generally, because this is pretty much every outcome we study in the social sciences, every regression I've ever run on any social outcome, your explained variation is very small. And just this year, I think earlier, a few months ago, Matt Selganic from Princeton University, he published a very interesting paper where they tried to predict 6 different life outcomes. And they did this like a challenge, like the Kaggle contest with the data science. They got hundreds of teams from all over the world. And in the end of the day, with all the best models and everything you can take from data science, there were some of these outcomes, the best they could predict was 6%, explain 6% of the variation. In some cases, maybe 12%. So when you say we can only explain 4% of the variation in age at death, I mean, it is a problem, but I'm not sure, is it indicative of specifically our field or this field, or is it more a wider problem in social science? And then I'm thinking, what do you think this is coming from? Is it we have 2 crude measures? Is it stochasticity? Is it because we didn't identify the right determinants yet? Or is it just the complexity of social life, that even if you're poor, or even if you have low education, we measured your income and it was low in some year, but there's so much more to social life that maybe it's just a drop in the bucket, and we can't expect it to explain more of 4% of the variation.
Thanks, Isaac. So I'll try to answer quickly. I think that the question of explaining variance in a data analysis and explaining variance in a longevity calculation are two totally different things. In the data analysis, you have a bunch of data that has been generated by some aspect of the real world, and you are trying to find variables that will let you fit a model to it. In calculating the distribution of the age at death from a mortality schedule, there is no variance coming in from the real world. The variance is a consequence of the mortality schedule. I think Mikkel showed, we've all seen them, a set of graphs of the distribution of ages at death over time. I think there were like 4 of them. They overlap completely. It's not like you're looking for variables to explain them. It's that's the nature of the thing. One of the most challenging aspects of science in general is figuring out how to deal with stochasticity. And it's the fact that income inequality can have huge differences in create huge differences in age-specific mortality, but only explain a small amount of the variance in longevity is a function of the nature of longevity, not so much the choice of the variable to explain it.
I'm not sure I follow you, because suppose we take, like in the Matt-Salgani case, they try to predict the probability of someone getting evicted at the individual level, which is of course very difficult to predict. But how is that different from predicting someone's time at death? So you're comparing, you said you're comparing the different socioeconomic groups, whether it's education or income or something else, and you're saying this only accounts for 4% of the variation. And most of it is, as we've seen, is the within group. So what I'm asking is, what is this within group? Is it?
So here's the difference. I've done this when I've been teaching about this thing, but suppose that I was able, if we had this meeting in person, at the beginning of the session, to hand each of you a lottery ticket and tell you not to scratch the numbers off of it yet. Is there any way that you could predict who's going to get the winnings and who's going to get nothing? Is there anything you could do to predict that? No. The lottery system is set up to make it completely unpredictable. People believe if they choose the number of their birthday or something like that.
I get what stochasticity means. The question is, how do we know it's really stochastic and not something that? So this is the error term, basically.
Because that's the way we calculate it. We calculate it just like a lottery. Right? The formula for the life expectancy says for the distribution of age at death is you take the probabilities of surviving up to a particular point and then dying. And we calculate that as if that applies to everybody, just as everybody has the same odds of getting a winning lottery ticket.
But this is exactly my question. Is it a function of our insufficient theory or information rather than the actual phenomenon? So
well, that's what that's why I'm using the lottery example, because I don't think anybody has
but the lottery is stochastic by definition. In this case, we don't know if it is really stochastic or if it's something that...
We do. Yes, we do. Yes, we know that because we calculate it that way.
I think it may be worth the distinction. It sounds to me that Hal is making Isaac, is not that mortality as an outcome itself is stochastic. It's absolutely not. And we know it's deeply unequal. But when we use a life table to analyze mortality, we have turned it into a stochastic outcome because of the nature of the model. Right? Is that a fair way?
Yes, that's
And so our problem as demographers is that unlike people who just use survey data where they have individual level data, and so they are trying to figure out whether in the aggregate these individual outcomes are predicted by some factors, we are in some sense, handicapping ourselves by using the life table models to understand mortality rather than just sort of mortality data directly. Is that we also gain things from that, right? Analytically and methodologically, but maybe for understanding these questions.
Yeah, and also there's no question that I think there's no question that the factors we look at in terms of socioeconomic factors create definite changes in mortality, and they show up very clearly when you look at life expectancy and the lifespan disparity gets sort of dragged along, but it's a weak signal of the socioeconomic variables.
Okay, Carol, would you like to ask your question?
Okay. So
hi,
Dustin, hi. Yeah. I'm extremely interested in this, in what Hal was saying. Of course, I think so, but that's not what my question's about. That I actually am coping with exactly that same issue and a lot of the things that I'm doing. But my question is really about for Dustin, a follow-up is what I was really struck by the geographic distribution of the lifespan disparities and inequalities. And I thought about what was said earlier today at the beginning of the entire symposium, really, webinar, was that if people live in a world with more uncertainty about lifespan, they kind of do perceive that. And their own perception influences their day-to-day attitude about the state of the world. Like, who knows, you might die tomorrow, is the attitude in Mexico, because there is a lot more uncertainty. So people have that in their heads, it's in their minds. And so I started to wonder if that difference in people's perception of their own uncertainty, if that's reflected in politics and in how they vote. So I was wondering, Dustin, if you have collaborations with political scientists which could address whether geographic variation in political behavior is correlated in any way with geographic variation in their actual lifespan inequality.
So thank you for the question. So I think that's an interesting kind of question, right? So really this kind of disconnect between, one way to kind of think of this, we know that there's differences in the social distribution of kind of sense of control, right? Which is kind of what you're kind of talking about. So for instance, if you're living in an environment where it seems like everything's just kind of, well, stochastic, right? There is no way to kind of control or constrain things. You're going to have more fatalism, right? You're going to have more kind of less of a sense of control. You kind of see that in the fertility literature, right? That's kind of sort of like an analog. It kind of comes to mind off the top of my head, where you have different environments where it's you have more fatalism is correlated with a less of a likelihood to kind of control fertility or use contraceptive technology in a way that's going to actually reduce fertility. So I think that's part of it. I think circling back to the political dimension, though, I think that's interesting that kind of view of the world, kind of a person's worldviews, for instance, can kind of affect their political decision making and political behaviors is probably true. But I don't think that is necessarily a one-way street, right? So I think there's this kind of synergistic relationship between the kind of reinforcing. It's almost like a circular kind of thing, right? Which comes first, the people's political or outlook on the world versus the political outlook. I think they kind of reinforce one another at a point. So the point is that it kind of goes back to this idea that all is going to matter, but it's really more about kind of what's the root cause here. The root cause is really about kind of the context that kind of plays out over a person's life course. The root causes are things that affect kind kind of shape someone's worldview, but they also shape someone's health chances. So in other words, I'm not so sure that a person's worldview isn't also shaped by the same things that shape their kind of actual health trajectory, right? So, you know, in other words, if you think it doesn't really matter, you might be more likely, if you have a lower risk tolerance, maybe you're more likely to smoke, but maybe you're more likely to kind of act in certain ways in terms of your political behaviors and your voting choices and stuff like that as well. I guess what I'm saying is I don't have an answer, and that it's really complicated, but that's probably a component of it.
Thank you. Thank you very much. So we are getting close to the end. Maybe I would like to ask one final question for Iñaki. Iñaki, thank you very much for your for presenting these new horizons and applications of healthy life expectancy variation. I have a question. I know you are still at the very beginning, but still, you know, in terms of healthy lifespan variation, there are many sources of variability, but the two main ones is in the distribution of the life years and in the distribution of the onset of morbidity. And what you have presented is the interaction between them. You know, you interact one with the other. Do you have any idea? If you have already looked into it, or if not, if you have some idea of which source of variability is bigger, which is from, I mean, the total variation in healthy life expectancy, is it more caused by variation in the morbidity structure or in the survival structure? Do you have some ideas?
Thank you, Virginia. I think you asked the million-dollar question. I don't know. I mean, this is one of the things I was pretty much interested in. At first, I thought that perhaps the healthy part of lifespan would be mostly responsible for that inequality, because at some point I thought that most of the lifespans are spent in good health. But I don't know if this naturally means that the fact that the longer part of the lifespans, the life chunks, are spent in good health, this means that they should be more responsible or less for variability. I don't really know. And I think one way perhaps to respond to this very important question is to rely on mathematical models and try to model and see what happens when when different chunks of your life are spent in good or bad health, because I think it's going to be hard at first to get good data about that. So far, I've been just playing around with toy models, just with cross-sectional data, which honestly, I mean, still a lot of work to do on that front. But this requires, well, you know that better than me. I mean, you published this paper together with Hal about these models. So my idea would be somehow to play around with that kind of models and see what comes out of it.
We should.
My question, we should work together then.
Definitely. Yeah. So, well, I think we should conclude here because it's really almost 6. And first of all, I would like to thank everybody, participants and panelists, for this extremely interesting event. We have really touched many aspects of the lifespan inequality studies. We went from the methodological talks of Alison and to the more biological questions and state policy and health declines and so on. And Hal has posed fundamental questions. What are we doing here, basically? Are we doing it right or not? Are we getting it right or completely wrong? So I think this was very successful. Thanks for for the high participation rate. We had many participants. I think at some point we were almost 200. So I think it's really good. And yes, so I would like to conclude with a big thank and just again stressing how important is the question of variation in lifespan. And healthy lifespan, which we have seen will be the new topic. So thank you very much. If Isaac and Jose would like to have also a very
no, just say thank you to the attendees, to the speakers for thought-provoking talks, discussions, some shameless advertising of postdocs, and that's it. Jose Manuel.
No, thank you, everyone. Thank you to the speakers, and for all those that post questions and that were not answered, feel free to email us and we can follow up on them. We're sorry we didn't have enough time to address all of them. I hope I get to know you personally at some point, but otherwise this was a very fruitful discussion. Take care.
Thank you, guys, for
Thanks very much to the organizers for organizing this twice.
Yeah.
and let's hope for a third one next year.
Yeah.
Yeah, let's hope.
More to follow. Okay.
Bye-bye.